I'm seeing on this problem that the degree of the numerator is, what's the degree of it? It's 3, the highest exponent, and the degree of the denominator is 2. So this one is a long division problem. So I'm on the side here, I'm going to set up my long division. X squared minus 3x plus 2 divided into, now you might remember this. If you don't, I'm going to remind you. Look, I'm missing the x squared term. So plus 0x squared, I want to put it in there, minus 4x plus 1. To do the long division, you're going to say, take this first term, x squared goes into x cubed, how many times? X. So put an x in the top. And then x times x squared is x cubed. X times negative 3x is negative 3x squared. And x times 2x, that's plus 2x. Line up the like terms. That's why I put in the 0x squared. And the trickiest thing here, I'm going to put this in parentheses. We are subtracting. That minus sign does distribute. So this becomes x cubed minus x cubed, 0. 0x squared minus negative 3x squared is 3x squared, positive 3x squared. Then negative 4x minus 2x is minus 6x. Bring down the 1. And then we will divide again. X squared goes into 3x squared 3 times. And then multiply. 3 times x squared is 3x squared. 3 times negative 3x is negative 9x. And then 3 times 2, that's plus 6. And then we are subtracting. So I'll kind of do that and say, remember, now you got to read it correctly. 3x squared minus 3x squared, that's 0. Negative 6x minus negative 9x, 3x. 1 minus 6, minus 5. Now, I get this, the degree, 3x minus 5, the degree of 3x minus 5 is 1. It is smaller than the degree of the divisor, so this is your remainder. What you do with the remainder is do plus the remainder over the divisor. So what we found out is that this division, here's the quotient. It equals all of that. So this problem, this integral problem, becomes the integral of x plus 3 plus 3x minus 5 over x squared minus 3x plus 2 dx. Let me kind of separate that division part from the problem. I know how to do the antiderivative of x. This part's going to be what? X squared over 2, or 1/2 x squared. This part's going to be 3x. This part is partial fraction decomposition. So once you've done the dividing, then you're looking at this. Oh, and I got to factor x squared minus 3x plus 2. So taking this part of the problem, it factors into x minus 2, x minus 1. It's going to be a over x minus 2 plus b over x minus 1. And so then you carry out that process to find out what a and b are. I guess we'll finish it. Okay. I was thinking to kind of leave it and say, now we've done enough, you finish it. But we're gonna do what I did the last time. Multiply the whole thing by x minus 2 times x minus 1. The left side will be 3x minus 5. The right side will be a times x minus 1 plus b times x minus 2. Then I can pick numbers. What would be a nice number to pick? Pick 1, because that'll wipe out the a term. Let x equal 1. It'll be 3 times 1 minus 5 equals a times 0 plus b times 1 minus 2. So 3 minus 5 is negative 2. Negative 2 equals negative b, and b equals 2. Then what would be a nice number to pick? 2, because that'll wipe out the b. 3 times 2 minus 5 is a times 2 minus 1 plus b times 0, which you don't need to write that. 6 minus 5 is 1. 1 equals 1a. A is 1. So at this point, the calculus problem, oh, that's the algebra. Yes? Yes, you could have done that. And you could have had a over x minus 1 plus b over x minus 2. You get the same answer. Yes, indeed. So, now that kind of question tells me you're thinking like a mathematician. Now what you would want to do is test it out and see if that's the case, okay? All right, so for this, let me go back to this part. I found what a and b are, and so my integral problem, sometimes the book says I equals, okay, it's x plus 3 plus a was 1 over x minus 2, b was 2 plus 2 over x minus 1 dx. And then see, that integral problem is real easy. This is x squared over 2 plus 3x plus the natural log of the absolute value of x minus 2 plus 2 times the natural log of the absolute value of x minus 1 plus c. So there's my final answer for that.